So I'll give a quick introduction. We're talking about sustainability in the built environment. My name is Mitch Gelber. I'm the CEO of Malaysia Green Building Council, and I also chair Malaysia Green Building Council's Carbon Score Initiative, which is targeting the decarbonization of Malaysia's building and construction sector. I'm going to do a brief introduction of our panelists, then we'll have about 15-20 minutes from each panelist, and then a group discussion and some questions at the end. So our first presenter is S. Ramesh, the General Manager at IJM Corporation Berhad, overseeing quality and compliance excellence while fostering sustainability initiatives for the company. With nearly 30 years of experience in the construction industry, he has a proven track record in project management, quality management, compliance, operational excellence, and sustainability practices. Next speaker is Gregors Ryman, Managing Director of IEN Consultants, a leading firm specializing in sustainable building design. With over 2 decades of experience in the industry, his expertise includes energy efficiency building design, green certifications, and sustainability in the building and construction sector. And our final panelist today is Ibsen Barangay, Regional Sales Manager at Carbon Core Technologies. A leading company, Ibsen is leading the company's growth and market expansion across ASEAN region. With a civil engineering background and extensive experience in the construction and building materials industry, Ibsen has been instrumental in promoting sustainable concrete solutions throughout Southeast Asia. So I think with that, we'll start with a presentation from Ramesh, and we'll see you all in a little bit.
Taller than me, is it? Ladies and gentlemen, good afternoon. I'm given like 20 minutes to talk something on this. And he already told my age, being 30 years in construction. So when this session was put up, so we were thinking, what is that we'd like to share with the rest of you? Then we came out and let's talk about sustainable practices. Not going to be something new. You would have heard it from many people. Today, the title is from not only I represent IJM, I also represent Master Builders, and I also represent Green RE. I'm in a various committee. So today's topic that I know we would like to talk to you is sustainable practice at construction site. Is it a hoax? You may ponder on it for a while. I'm going to leave it to you ponder, but I'll do what I needed. Okay? When you hear these words, sustainability, sustainable construction, sustainable development, go green, great, right? Sounds sexy, sounds interesting. Everybody wants to go for it. But we are in a construction industry. I've been in this industry for long enough. To dissect this topic, we need to move around and see what is that impact. Hang on, before that I need to have my clicker. What is the impact from construction industry? Because when you understand the impact from the construction industry, then you will understand what kind of practices we can mitigate or do. I'm just going to run the whole thing, it's easier. These are the impacts, and these slides I use it whenever we do a presentation at Green RE when talk about sustainable construction. Why is that this impact? I want to know. It's like consumption of natural resources. Many of you are from construction industry, I believe, or property development. Regardless of that, even this building that you are here, we are using natural resources. Doesn't matter, wood, metal, aggregates, whatever, is all we are using it to build the space that we are occupying. Yes or no? You may not, but this is what we feel. Next is environmental pollution. When we talk about environmental pollution, the construction industry is polluting. Terrible, right? We pollute the air, pollute the land, noise pollution, sound pollution, whatever you call it, all that we are doing. Thirdly is lifestyle impact of the material extraction. The effect on the landform, the effect on the landscape when you extract this material. Imagine that you are extracting aggregates from a mountain. Maybe probably that area was occupied by the Aborigines and Orang Asli. That's it, you've changed the landform. You may even change the ecology, the biodiversity of it. Who's the cause? Me, you, the government, the developer. I'll let you to ponder again. Next, generation of waste. This industry is known that we generate waste. If you are from construction side, I've been long enough. You know, we call it the ro bin or roll off, roll in bin, that kind of a bin. You can see every day that bin will go out from your site, and bin, where does it goes? Those days it goes to don't know where. Nowadays we know, at least because there is an act to control it, the authority a bit better in some enforcement, and maybe it goes to some landfill. It goes to landfill, most of it. High consumption of energy. We use energy. Doesn't matter scope 1 or scope 2 emission, we use energy. The other one is greenhouse gas emission. Not only because you're using direct fuel, it's also when you're using solvent, using other chemical, there are GHG impact. Agreed? Good. Then what for? We are the cause. We are the solution. Don't need to construction, right? Anybody agree here? No construction? Not required? Why is that smile? Saya cari makan. This is my rice bowl. I need to have construction. This is what we are, all right? But we know the impact. We need to have construction. Construction is known for a catalyst of economy. So we need to do this. But understanding impact, when you know your risk, when you know your impact, you know you're something not right, what can we do? Hence comes sustainable construction. Sustainable construction, I'll put it very simply, is the primary goal is to understand what is that impact, how we're going to mitigate. And to understand that decision that we're making today have a long-term and short-term impact. But whenever sustainability is mentioned, it cannot escape from looking into these three pillars, the three fundamental pillars, which is next one. These three pillars, a lot of time when people are looking into one pillar. Understanding that the integrated, the cohesiveness of these three pillars must be made. So construction industry, we look into environmental, economical, and social impact. There are many things that we can go about and get it done. I just touched on environmental. I spoke about pollution. What can we do? Can do so many things, right, to mitigate it. From protecting biodiversity, have a better waste minimization, water conservation, water protection, whatever you want to call it, all right? Then social. Social mostly is about well-being of the people or the social well-being of the community, health and safety of that. They need to be ingrained, there need to be cohesiveness in all that. And next thing is, we are not doing it for, it's not voluntary work, right? There is a profit involved. There's an element of profit. There's an element of making money. You need to make money. Make money with this consciousness that we are also having some impact to this, the world that we are staying, the earth that we are staying. So what we are going to do? So sustainable construction, whether it is going to help the impact or mitigate, it all depends on us. So these are the few things you can do. From social, you can have the local communities development. You can also look into your profit without harming that environment. So I'm going to summarize a bit later here, is on the green actions. What can we do at the construction site? This is what we do. You know, a company like us, big boys in the town, we practice a couple of these things into our sustainable. We embarked, my company embarked on an environmental management system a long time ago, right? Why we went that? Because one is to be in the business. Is another marketing also. I will put it in the marketing, to be in the business, because the big jobs coming in, they said, what are your organization doing in sense of environmental management? Hence we went to environmental management system. But in that same time, we also look into green action. So what is the green action? We have, the key thing we did was having a waste management of material. So we have waste management practices. Then efficient use. What is efficient use of construction material? We realize that time when we don't have a proper strategy that how am I going to be efficiently in it's like temporary work. Temporary work, we have a lot of timber waste generated, and that also not efficient in sense of construction material. And if you don't have a proper tool for your workers to cut the material, there's also waste, there's also not efficient use of construction material. And you don't plan for it. You don't dry lay your area like tiles. You're not efficient using, you're going to like waste. So these are the few things the green action can be taken. Avoid or minimize pollution of construction site. What can we do? We can have environmental management system. Do we have enough regulation in this country in sense of pollution? Let me tell you, there are more than enough. I have a list, but I had to open up my phone and show it to you. We have more than enough. I just quote the most important one from the DOSH or EQA, Environmental Quality Act. There's enough. But are we doing it? We just comply to that is sufficient. Saving water, construction, being energy efficient. How to be energy efficient at construction site? Mitch and I was discussing, we said, hey, nowadays looks like using electrical powered machinery are more energy efficient compared to using a direct fuel. That kind of a technology is being thought of. Apart from that, what are the energy that you use at a site office? Your equipments. Are you using an energy efficient equipment? Your site office, are you designing a site office to be energy efficient? Are you looking to the OTTV of your site office? Yes, all can be done. Do you have natural light coming to your site office? All that can be done, and also lastly is using a green product. Why green product? Because you know that product has gone through some kind of accreditation. These are the green action can be done. I'm going to show some photos to you. These are photos from my sites, all right? We have the top one, okay, there's two are the areas where we do for the silt content recycle, to clean the silt content. And this is all protection of the part of the environmental sedimentation control plan. Oh, it's not that we want to do environmental sedimentation control plan. Oh, we are a good guy. No, it's already in the requirement. It's already in regulatory requirement. Supposed to have it, and we had it. We made it better. That's all. We made it effective. Wash through, silt pond, silt fence. Some guys cleaning up all the dust and particles. It's partly regulatory requirement that we comply. Apart from that, monitoring the energy use at your construction site. Look at this site office. We have a long overhang, so don't have lesser heat. Basically talking about OTTV, white colored, right? We have more natural coming into our site office. Better toilet facilities. I started 30 years ago, toilet facilities, you can't dream of it, it was just across a drain. And you used it before, is it? The toilet was just across the drain. Now we give better facility to our workers. We're having jaw crushers, regular maintenance of equipment for reducing emissions, not only emission when the machines are more effective. These are the green actions, using planter box in other areas to save water. All that few things you can do. This guy is here, you don't idle. Not only that, idling of machine and maintenance of the machines. All these are the few green actions can be done. Okay, now, I showed you all that what can be done. I showed you the impact. This question still persists. Is that a sustainable practice at our construction? Is it a hoax? So what does that word means? That brought to this terminology of greenwashing. What is greenwashing? False solution. You're just giving, just to create impression that you're doing something about it. Distract or delay the concrete and credible action. This is greenwashing. That's what I think I'm going to leave it to that. So in greenwashing, what are the few things that takes place in greenwashing? Ambiguous claim. They will say, we are very energy efficient. We are using energy efficient machinery. Ambiguous, right? Irrelevant claims. Irrelevant claims are like this. It is truthful, but not relevant. Say, now we are using asbestos-free roof. Hey, probably asbestos has been banned. Yeah, it's right, truthful, but irrelevant. These are greenwashing. Lack of proof. We don't have enough evidence for it. You will just, in Malay we call it syuri tembak. Deceitful labels. You just go around, you say, oh, we are eco-friendly, care for animal. Deceitful, huh? I'll show you a slide later about deceitful labels. False claims. This is outright they're lying, all right? Selective disclosure. It's like, I'll show you some example about selective disclosure. Probably a few of you may agree, may not agree. But this is, you just wanted to say something nice. That's it. You hide all the other environmental effect. I didn't. I showed you all the impact earlier. You take out the aggregate from the soil, from the earth. That is impact. But they say, no, we have been very, very careful in sense of the waste management of the thing. That is selective. So these are the few things that when you see this kind of a thing, you know it is a greenwashing. Then it is hoax. Let's ponder this. Zero carbon airport. Good? Have you seen this? Have you heard it? Zero carbon airport? No. You ever heard zero carbon airport? The airport, the building itself is zero carbon. But where is the real emission coming from in the airport? You jet from somewhere far away, that's where the real emission. So by saying that, it's actually saying, oh, my airport is fine, but where is the real emission? You need to keep the whole thing. Next thing is electric vehicle. This is Elon Musk going to get mad with me, okay? You don't know what's happening to the battery, where the raw material for the battery coming from, where's the end of life of that battery, okay? And what is the impact from other things? They only talk about, oh, we are saving energy. Apart from that, show the whole thing. Be open, be frank about it, and address it. Green hotels, we are using green shampoo, that's it. Or we recycle our towel. Is that green hotel? What is the energy? No, do you know the hotel building energy intensity can go easily around 280 to 300 kind of a kilowatt per meter square per year. That's high. You need to focus that. Carbon offset, that's another one. I'm going to plant somewhere else. What is the real impact? We wouldn't know. These are the few things. Look at this label. How many of you have seen this label? Earth-friendly, eco-friendly, heard about it? Somebody was trying to tell me something today outside. They said we are eco-friendly bag. I wanted to give a lecture to her, and I just told her, please attend my lecture. So maybe she's here. I don't know. I said, please attend, I'll talk about it. No, she said eco-friendly bag. I just look at it, I said, no, don't tell me all these things. I look at it, I want to tear the bag. It was made from the plastic, okay? Okay, this photo. I need to be mindful of my time, Mitch. You know I can talk. Thank you. 2 more minutes. Holy God. I started late. Is it a good building? See, this is a green roof. But this green roof is using artificial grass. It's artificial grass. Oh, but they labeled it, oh, we have a green roof, nice. Okay or not okay? How many says, that's good, that's great? Yeah, it still will have some shade, some no, maybe RTTV roof transfer value will be lower. Good or not good? If you dig further, this photo was taken, this was a R&D from a company who were looking into using grass to generate electricity. It's called a trioelectric effect. So they have this small artificial grass where with the wind direction, doesn't matter any direction, it will able to generate electricity. Good? Now better? Look at the design. Center, we have full natural light coming in. No cross ventilation will be perfect. Look into the whole thing. Before you want to make some being judgmental, or I said that the impact, this is only artificial grass, but they are trying to do R&D, artificial grass can be better. Real grass I put on a rooftop, what do you want to do? Fertilizer, etc., caring for it, maybe a bit tough, maybe not, but this is a research done. The problem is the material they use is called indium oxide, and that is very highly toxic chemical to use or to generate electricity. You may Google it about it. It's called, let me see here, it's called triboelectric effect. But indium oxide is an issue. Same like the electric vehicles. So whenever you see like this, go in deep dive, whether there is really benefit out of it or no. That's why I start calling it, whether it's a hoax or no hoax, it's all. What can you do? Now all of you are listening to this. You're going to go to the end of this session, going to be a hoax detector or greenwashing detector. Okay, what can I do? First, check for third party. I already given you the third party certification. I give the sample of eco-label. Vague languages versus quantifiable metrics. No, yeah, same thing, right? I have some things to quantify. Track record of the company. Whether they really have done it. They have proper certification. They have done that in sense of sustainability. What is holistic approach? Holistic approach is like focusing the few things that I showed earlier, from energy, water, pollution, waste management, well-being of the people, well-being of the community. This is holistic approach.
End-to-end sustainability is about looking into that. I'll call it upfront carbon. They know the A, B, C, D, upfront carbon and operational carbon, end of life, and also the benefit after the life of that. So you look into the whole end-to-end sustainability effect of the development of project. Material sourcing and supply chain transparency. This is required. When you ask for material, how they source the material, they have certification, or now we talk about EPD, right? EPD is something that you really want to do. Go. In Malaysia, we are lacking of it. Of course, our neighboring countries, they're already moving towards that direction. Energy use and life cycle emission. Long-term maintenance costs. You need to look into whether that, whatever that we are doing, the material use, do we have a long-term maintenance cost? Is it durable? Post-completion. So one of the way to detect. End of the day, I want to be a detector. Focus on specificity, transparency, and measurable data. Now you all have a detector. This is what I want to say about the end-to-end. So this is upfront. They're both basically product and the construction process. Then you have the use phase of the building. Then end of life. Then even there is a benefit. So this is what the direction is moving on, the life cycle, emission or life cycle. So you need to look into the whole thing end-to-end. You become a host detector. Now you're going to be a HOX defender. Compliance with requirement. I mentioned to you, you don't need to do a lot of things. You just comply with requirement. We have sufficient. I told you EQA, DOS, CIDB, mention it. That is the only thing we're lacking is enforcement. Oh, we record it. Have best management practices. Specific language of what you're doing. Okay, say the target that you're going for. Backup claims with some third-party certification. Be honest about your journey. Okay, we are doing. We know we are damaging the environment. We know about that. We're working on it. And make sure initiatives are supported by a wider changes, operational changes. I'm going to share some photos. Yeah, we can do all that, be a defender. This photo that, when we did this project, the one thing that we felt and we learned was this. For a project to be, a construction site to be really sustainable or green, every party need to be involved. There must be integrated construction, integrated design, integrated thoughts, cohesiveness in that. So this project is one of the success stories that I like to share because the client, the PMC, the consultant, everybody got involved and he said, let's look at not only environmental issues, let's look at the well-being of the workers. They came up with a lot of few things. So we also proposed as a contractor. The consultant came about and we did it. So this project came with I also have my beam modelers at the back. We modeled it, and this one, automatic climbing system, it focuses on zero gap policy. It's not only as a contractor, the client came, the designer came, and we can also cast it at least easy, 6 stories high, like 6 floors, faster construction, efficient. And next one. This technology was from in Australia. They brought it here. They said, let's do it in Malaysia. So we went in. Well-being of the workers. Used to be their work close to the edge. Now it's behind the protection. We can still install the facade, no issue. And much more better. Faster? Yes. For what reason? Sustainability. On what? Social aspect of the workers and well-being of our workers. So these are the few things we explored. You see this guy? He's now at behind the edge protection. That means he's depending on two. This lifeline and also this. His life is cared for purely because of sustainable practice. Similar photo, best approach. So we did some time saving, was launched from inside. I can show you a lot of photos from our sustainable practices. I just picked up one that I felt interesting to show to you. All right, I'm not focusing on environmental, but I want to focus on social. Now, ladies and gentlemen, sustainable practice at construction site. Is it a hoax? Is it a greenwashing? It purely depends on your action. Ask yourself that question. Work together with the whole team. Have an integrated construction, integrated design. Thank you. Mitch.
Okay, I think we'll move on now to Ibsen or Gregors. Gregors? Yeah. Okay, we can arm wrestle for it.
Yeah, thank you very much. I'm Gregors from IN Consultants. There's a slide. You go one back, but never mind. So I'll talk a little bit about 3 case studies of best building practices. And I've been living and working here for the last 20 years as a green building consultant. So the first case study is on maintenance, which is quite important, and I think Ramesh also talked about that. It has to be maintainable, so this is the ST Diamond building in Putrajaya. And we designed this building to be green, but then once you leave the building, you sort of hand over the baby to the facility manager. So we had this head of facility management, Juan Hamida, and she ran the building for 12 years. So I took the opportunity on the day before she retired to just have an interview with her to see, so how was it actually to run this building? So with this interview, you can actually play it on your own from this link. I'll be happy to share the slides afterwards. And not only is this a highly efficient building, and she managed to maintain the high efficiency, but what was also interesting was the following points, that because most people think, having a green building is very expensive, and it's difficult, troublesome, and expensive to operate. And she basically said, in her experience, because she's been a facility manager all her life, this green building had actually been the easiest to operate, because for example, we had the design for daylight, so very rarely she had to change the electric light bulbs. We used variable speed drives for motors and fans, which of course means when you start up all this equipment, it doesn't break down so easily because it's a more sort of easy on the motors. So actually, she said, not only was it easier to operate in a normal building, but it was also cheaper, and basically putting to bed all these misconceptions. So listen to the interview, just giving you a few highlights. But of course we have to design correctly as well. So the other one I wanted to share is about new construction. So this is an electronics factory in Penang. And what was interesting about this project was the client basically came to my office here in Bangsar and said, I need to get a cheap building. I want a cheap building. And that's what he got, right? That's what you are looking at. He's very happy with the building. And as you can see in the bottom left corner, the client in this case meant a cheap life cycle cost, because he knew he had to pay the energy bills. So he knew it had to be very energy efficient, this building. And he knew that it was important to have a building that's very conducive to the staff working in the building, because with happy people, you get higher productivity, less sickness, and so on. So, but very few clients, I've only had one client like that, with this kind of awareness, and that was this guy. So I'll just show a little bit from the factory. This is the one, it's in Batu Kawan, near the second bridge in Penang. And a couple of the project highlights. One was how this project started, because the client wanted efficiency. So he actually looked for the engineers first, the energy efficiency consultant, not the architect. So this guy from Transolar in Germany, he was contacted first, and then he basically said, why don't you call Gregors, he's in Malaysia. And then the client was very happy with what we did, and he said, great, you're on board. Please recommend the architect, right? So me as an energy efficiency engineer was actually the first person on board, and I was in the position to say this is the architect we should employ, right? So I basically recommended 3 architects then that we knew we could work with. One of them won, and the rest is history, right? So it was not that I was designing the building, but the whole design revolved around efficiency and getting that right, and the architect knew that as well, right? But had to consult with me. The other highlight is, for example, on the cooling system. So here as is the case in many buildings, the engineers will take the drawings, make various assumptions, and come out with some kind of a cooling system sizing. In this case, we did the detailed energy model, and we basically told the engineer, actually, because we designed it to be so efficient, using passive design and so on, we can get away with a much smaller chiller plant. So we compared notes. He agreed, okay, his calculation was a bit too simplified. And he basically said, okay, let's go with your chiller sizing. So just by doing this, we already saved the project 5 million ringgit straight off the bat. So that means my fees were like paid back many times over, straight away. And of course, the biggest saving for the client was then the energy savings, because they had a factory in Penang already. So the new factory had a 40% lower energy consumption. And we did some surveys showing that the occupants were very happy. We just asked, it was an anonymous survey, do you prefer the new or the old factory? And 90% preferred the new factory. The old factory is just like a standard factory without windows and all that. So I won't go into all the details, but here's some of the passive design features, basically working with the climate, trying to keep all the direct sun out, letting the diffuse daylight in, insulating where necessary using plants. So one thing, for example, is to have these skylights throughout the factory, and even when some direct light comes in, we had these screens to deflect or diffuse the light. So very even lighting. On the active side, we used something called DOAS and slab cooling. I'll show some slides. So the slab cooling is basically these red pipes. They go into the concrete slab of the factory. So we laid about 65 kilometers of these pipes. They're cooling down the slab to about 21 degrees. So 1/3 of the cooling in this factory is actually done through the system. It's a much more efficient way to cool instead of pumping all this air around. And we can do it at a higher temperature, which also means we have a much higher chiller efficiency. This is a schematic that shows that cooling system in the floor. And then, of course, we just had to make sure we had the right insulation in the floor so we didn't lose the cooling through the ground. So we tried to calculate what is the real payback time for a factory like this, because the client wanted a cheap building, right? So what is the ROI? Most people, when they come to the factory, they're like, wow, this looks really expensive. I mean, they're very impressed. I even had a taxi driver. He thought, wow, this is a resort or something. I was like, no, it's an electronics factory. But actually, this is the cheapest thing you can build. If you look at the life cycle cost and factor in all the things. So what is the biggest operational cost? In offices, it's definitely salaries. For some factories, of course, they use a lot of on energy as well. So this is the stats from my own office here in Bangsar. So you can see the big post, the black one. This is the salaries I pay out to staff. And actually the next one, the big blue one, also has to do with like company trips and other benefits. So it's really almost entirely what you spend on your staff, not really your energy bill. Doesn't really matter too much. And in Malaysia, I saw this study that basically said people are actually quite unproductive. 66 unproductive days for the average Malaysian worker. It's twice the figure of that in the UK. So either you're an MC or you suffer from presenteeism. So that means you are present at work, but you're not really there, right? You are zoning out. And because maybe it's a terrible room you're sitting in, right? No view out, noisy aircon, smelly, whatever. So I just happened to see this LinkedIn post by one of the staff working in this factory, and he was basically like really happy. And you can see after 6 days, there was already almost 500 likes and 52 comments. So I just copied down some of the conversation. So basically, people were like really appreciative and amazed by this workplace. And here's a video that we did at the book launch where people were also just really praising the building. So what is the salary benefit actually of having this much better work environment? So of course it's difficult to measure productivity, but there were some studies done, for example, in call centers. This is a study from the US where they had several call centers. And they basically look at, okay, how many phone calls can each employee do per month? And they saw, interesting, the call centers which have a window, we can see people can do 6 to 7% more phone calls per month. So they did the calculation, what if we retrofit all the call centers, so they all have windows, and that would have a payback time of just 4 months. So we asked people also anonymously what do you appreciate about this building, and what was quite interesting was contact with nature was 1/3 of the answers, and that's not really rewarded in the green rating tools, the contact with nature. The next one, also 1/3, was beautiful building design, and that's also not really rewarded. So I think we also have, as an industry, maybe to encourage that more. And then the next one was the conducive work environment. So if we look at the payback time, so I did this graph. So if we look at energy efficiency only, then this building would have a payback time, which is up on the top there, of about 8 years. But since we introduced the windows, right, which would increase productivity with about 6%, that means that your payback time now has dropped to between, what does it say, 2 to 3 years, or 3 to 4 years. But of course, this is not just a window that we're giving them. We're sort of immersing them in a forest. So other studies show that actually once you are in this much more connected environment with daylight and so on, a productivity increase of about 14% is more reasonable. And then of course the payback time drops to less than 2 years. And here we are not even including staff retention, which can be a huge cost to factories, because some factories spend like 9% of their operational cost just retraining staff. So actually it's probably even better because they have a very good staff retention in this factory. So the ROI is basically very good. And what's next? Well, this factory owner needs to have a new building built, a new factory. So they're basically saying, give me another cheap building, right? So we are now repeating the process. Okay, then the third case study I'll just show is on retrofitting. Because that's of course very green, you don't have to build something new. So this is for the university building in Singapore. And when do you know that it's time to retrofit? Well, when you see this kind of graffiti on the wall where a student had written, I just want to be 1 million miles away from here. So probably a good idea to do a retrofit. And of course the university had two choices. Do we want to tear down the building, or are we going to retrofit? And they said, let's do the right thing. I mean, this is a school of the built environment. So retrofit was, they looked at the carbon calculation, and it would be much better. So this building is from the late 70s, early 80s, and you can see it looked like really dreary and not very nice. It's a school of architecture, actually. So we basically retrofitted it we changed the facade completely, all the M&E systems as well. And this is actually a photo. It's not a illustration of the final product. So a much prettier building, worthy of an architecture school, but it also performs very well. So for example, the facade, this facade was facing west, which is the most difficult facade because you get the low sun every evening. So we worked closely with the architect to see how can we design this facade so we don't get glare and people don't pull down the blinds, and then those blinds will stay down forever, right? So we introduced a very long light shelf. There's also some trees. So with this long light shelf, the sun only starts to enter really past 6 p.m. and then it's also coming through some trees. So actually the sun is not very powerful at that time. So the facade is actually built without any blinds at the moment. That was saved away. And it has been operating for more than a year like that. And here you can see the corresponding light shelf and some daylight studies. I won't go too much into detail on that. Another thing we did was we introduced what's called hybrid ventilation. Prior to this, I actually used to be a student there myself. So back then, in my student days, about 20 years ago, I measured 16 degrees indoors in some of the lecture rooms. And little did I know I would come back many years later to be the energy consultant for this project. And of course, we started out by measuring how's the building operating. It was still 16 degrees. So for 20 years, they've just had, or more, just this terribly, really cold environment and they're wasting energy. And we managed to, with this hybrid ventilation, where we still air condition, but we combine it with these ceiling fans that are completely silent. So you have a constant breeze. It's not very strong. I mean, paper won't move or anything, but you have this breeze. So once you do that, you actually can have a temperature between 26 and 27 degrees. And it's been operating like that for more than a year. People are perfectly happy with this. So we increased the temperature set point by 10, 11 degrees and made people much more happy. I'll just skip past this one. So the other thing we did, this was an architecture school, so they like to work late hours, especially around deadlines. So we basically made the facade so you can open the windows on both sides and have cross ventilation. So if you choose to stay all night and so on, you don't get the aircon. And then we had these sensors at the window. So if the windows are opened, the aircon cuts out automatically. So this also works quite well, and it's one of the energy-saving features. So you can see if we compare the measured energy consumption before and after this retrofit, we had a 5-fold drop in energy consumption. And this is without any solar, right? The solar panels are only coming on end of this year, and then it will be an energy positive building. So this is purely from energy efficiency and energy conservation. And if we look at the carbon balance from building a new school versus doing a retrofit like we did, then we also have a very substantial carbon saving. So quite a good reference. And then for the opening, we had the Deputy Prime Minister of Singapore, and he basically said this should serve as a good example for everyone to follow, for the nation and I guess beyond as well. Yeah, thank you very much.
Okay. Previous speaker is very tall, so I have to put it down. Good afternoon, everybody. Thank you very much for your presentation. It brings me back as well. So that was my school as well when I was taking my graduate certificate, and I was on that building. It's very, we cut all of the electric fans actually because it was really. Okay, so Ramesh has given us a very wide overview of the whole operational embodied carbon, or the total life cycle of any construction industry. So now, and then Gregor has already given us an overview in terms of the operational side of it. And what I'll do is that Carbon Cure is now on the embodied carbon part. So it just meets, I think it just falls nicely into place. Okay, so here's just the agenda. I'll just go through it. So we will talk about the embodied carbon, what it is, sources of CO2 in the industry, especially I'm just talking about how concrete is made and how it contributes, and we'll go back into on how concrete is. Next is that the CO2 reduction evolution, what are the mitigating measures by the industry itself, because the industry in itself is being said that it is it's the dirtiest industry, most polluting industry. In any case, it will show you how it evolved. And then after that, we'll give you an alternative on how we can lower down the CO2, or at least the CO2 to be embodied, who we are, Carbon Cure, who is Carbon Cure. Sorry, that's two, who. So the other one is supposed to be what. And the different technologies that Carbon Cure is, that we are doing right now, giving, and our global presence. So I think everybody already knows what is embodied carbon. I think there are two types of carbon in a building when you make it. So one is the operational part, and one is more in the embodied. The embodied part is where all of the materials that are being put in and how much CO2 is being used in order to make that material, in order to make the building. And from what we understand okay, probably in the next slide, that's what I'm mentioning. The operational side will be around 51% of their total CO2 in the life cycle of it. And then the other one will be the embodied carbon, which is 49% of it. So what we are seeing here is that by 2060 is that the building bank will double by 2060, and that is an equivalent of about one New York or Manhattan city every day for the next 30 years. So just imagine how much concrete is going to be used, how much materials are going to be used, whether it's steel, glass, just imagine. Okay. So the next one is that because of this, designers, developers, architects are now, just like Gregor is now trying to understand and how to really lower it down. Now there's a race to it. So from 2020, 2040, at least a zero, the initiative is to have a zero embodied carbon emissions into that building. Okay, I think everybody already knows this, that 8% of the total CO2 global emissions is coming from concrete. However, concrete in itself, whatever it gets, is just a legacy from what it is, which is cement. So most of it will be coming from cement. Probably everybody knows that cement is just a raw material for concrete. You have aggregates, sand, and water, and the biggest part of it is really coming from cement. So later on, you will see how, giving you an overview on how cement is being made and what the industry is doing about it as well. Concrete is the most used construction material in the world because it's cheap, very durable, and second only to water. Okay, just imagine you use water, and how much you use water, and then how much you use concrete. Okay, so here's just a very simple overview in how CO2 is being moved from cement into concrete. So from the raw material of calcium carbonate, which is the limestone or marble, it's being heated up, and you heat it up to about 1,000 degrees centigrade, 900 to 1,000 degrees centigrade. It's a very energy-intensive industry, and then you break it down into lime and CO2. The lime is the one that goes out to make the cement and into the concrete, and then CO2 that is where it's coming from. So here it just says from EPDs from US, Portland cement, it's about 922 kg, or 0.922 tons of CO2 per ton of cement. Okay, so that is quite high. Okay. So, knowing that where the CO2 is coming from concrete, now we have to go down back to the basics of raw materials and what makes concrete. So here are the sources of CO2 which is coming from the cement. I'm not so sure whether most of you will be familiar with this. This is how the cement is being produced. Mr. Ramesh already knows this very much. Okay, so it starts from quarrying, then you crush it, blend it, together with some other materials, you blend it, you grind it, so making stone into very fine powder. You preheat it to 1,000 degrees centigrade, and then you clinkerize it. Inside is about 1,300 degrees centigrade. And then you cool it down, you mill it, and then you pack it. So very basic, but it's just that it's very energy intensive in terms of fuel, in terms of electricity. So just a snapshot of of how it is being broken down into the sources of CO2 emissions in the cement. So you have calcium carbonate here, calcination. Here's just where the CO2 is coming from. So that is about 502 kg per ton of cement. And then you have another one, which is the combustion, the fuel that is being used here. If it is coal, is higher. If it is natural gas, it will be lower. If it is an alternative fuel that is being used, it will be lower as well. But so far, this one is using coal at 262 degrees centigrade. Sorry, 262 kg per metric ton of cement. Of course, as I've mentioned, this involves grinding, moving a lot of big machineries. So power, say for example, here is using 100% coal, so that's about 72 kg. And then the minor ones are about 26, so all in all, you have 862 with this calculation, and it can range from 650, which is the most efficient, and to the non-efficient right now to about 900 kg of CO2. So now if you look at all of this, the biggest one is really here, and here, here. And actually the industry is already doing something about it. Okay, what are the mitigating measures that are being done by the industry in itself? This is way back in the 1900s or even 1800s. That is how cement or clinker was being was being produced. So it's just your typical oven or something, and then it started to become more modern, but uses about 2,000 kilocalories of fuel. Then it evolved from here, LEPO, suspension preheater, and as you can see, the energy is going down because it's getting more and more efficient. And whereas it is right now, as I've mentioned, it's about 862. So you can see even the industry in itself, beforehand, 1800s, 1900s, they are already, being environment friendly, thinking about the environment. So that from that 2000 up to now, so that's about 1,000 to 1,200 of reduction in fuel in making cement. So that is about 340 to 410 kilograms CO2 reduction. So now in terms of the power, it's very energy intensive because you have to grind it into very fine particle into a level that is, the powder, the makeup that is being used for the face. That's how it is. That's how fine it is. So, yeah, from more than about 40 kilowatt hour per ton of cement, so now it's now down to about 20, even 20 kilowatt hour per ton. So again, from the fuel, half. From the electricity, it's also half. However, and then the other one that is being done is the use of SCMs. So you can see here in terms of the clinker, or what we call clinker factor, or the substitution of other materials to that of cement, it actually went down from 0.9 to 0.81. Later on, you will see it's now about 0.71. And then the other one is using slag, other materials. Actually, there are now tests that are using zero cement, 100% slag, and I know of a project that they want to build a house that is just made up of 100% slag. Of course, LC3, limestone calcined clay cement. So this one uses less energy. So if we look at a while ago, it's about 800. This one uses only about 400 to 500 kilocalorie per ton of cement. So this is another one. It's not it's nearing soon. In one of the countries here in ASEAN, we'll be putting up a plant soon. Now, why do I put this all? As you can see here now, this is coming from the probably I'll move on to the next. So this is coming from the International Energy Authority website. As you can see here, this is the emissions coming from cement. So it's projected to about to add 7%, and here are the mitigating measures. So it will lower down by 26%, and here are the other mitigating measures. So material efficiency, energy efficiency, bioenergy, hydrogen, and of course CCUS, which I think everybody is already familiar. CCUS as carbon capture, utilization, and storage. So with all of the pledges that are being put in under COP. So from 2022 to 2050, it will reduce down up to this level. And what is very interesting here is that the biggest jump is really on the CCUS. So there's already a lot of technologies going on out there in terms on how to do carbon capture, utilization, and storage. Probably you've seen in commercials such as Exxon or the carbon capture and storage. Okay, just some examples of carbon capture projects. Singapore, they are in, there was this one pilot plant together with the Public Utilities Board for water and aquatic of California. So what they did is that they put up this pilot plant that captures the CO2 from the atmosphere using the using seawater. So I think it will be it's already operational actually. So the next one is that Cemex, all the cement plants, is that they are now capturing their CO2. And then we have here also Heidelberg. I think the best example is in Edmonton, Canada. So they have already put that to capture the carbon. Now, from what we are hearing, what we are seeing is that it's all carbon capture and storage. So carbon capture and storage, that you capture it and then change it chemically to be inert so that you can have it stored somewhere. So just like those emptied oil fields, so that is where you put it back. Okay. So, and then what we are seeing is that carbon capture and utilization is lagging. So currently right now, the carbon capture and utilization is actually capturing the CO2 and then put it in your soda, in your Coke, Sprite, your sparkling water. So that is where it's all going a lot. Beer is also another one. So that is where it is. So there's not really a permanent embodiment of this captured CO2 or sequestered CO2 from the atmosphere from anywhere into something that is beneficial also to the industry. So that is where we come in, and that is what we're saying is that why don't we mineralize concrete? A while ago we were saying that, you know, calcium carbonate, you heat it up, lime, and then CO2. And now what we are trying to do here is that bring back the CO2 into the lime and permanently have it in the concrete again. So we're somehow reversing back the process. So just a bit of advertisement, but in any case, this is a very new and novel technology. No? We are called Carbon Cure, founded in Halifax, and we are a winner of the Carbon X Prize. Also, probably you can just look at it online, backed by capital VCs, and one of them is Breakthrough Energy Ventures. This is by Bill and Melinda Gates Foundation, so it's one of our. I won't go through here, but what is Carbon Cure? So we give technologies in order to facilitate the CO2 to be embodied in the carbon. So we have the technology to put carbon inside the concrete. Probably you're thinking, how can CO2 as a gas? Probably. If I asked, everybody thinks that it's all gas, right? So how are you going to put it inside the concrete? Where? So this is the good thing about the technology of Carbon Cure. So just going into the cycle, as I've mentioned, just putting back the CO2, it becomes calcium carbonate again. Okay? Yeah, so I was saying, how does it look like? Is it gas? Is it solid? Is it liquid? The technology of Carbon Cure is that we still, what we pump in or what we inject into the concrete is actually solid CO2. So probably you would have heard of dry ice. So solid CO2 is dry ice. It's putting it into the concrete. Any? Okay. Okay. So anyhow, the chemistry is like that. So what we do is that we just, you know, that cement together with water, it produces lime, and the lime together with CO2 produces calcium carbonate. So we just regenerate it back. Sorry. We can talk offline on this one, but all I can say for now is that no, there's no, in terms of durability, probably the madam here is thinking about carbonation issues, which is very different from this type of carbonation. So research shows that this is how it looks like. It's calcite. It's already inside embodied into the carbon. So what it does is that becomes a seed in the concrete that also promotes further hydration of the concrete to make it better. And the calcium carbonate in itself reduces the porosity of the concrete so that it makes it less permeable, so it's very durable. This is just how it looks like. Probably I'll skip that. Okay, because it's a very novel technology, no standards on it right now. Actually, even though we're certified to ASTM C494 in the US, however, it's more on certification for admixture. So it's on the admixture type S. But one example is that in Singapore, government bodies are now not really mandating, but they have opened up a field wherein everybody can use carbon mineralized concrete. That's what is being said. So BCA, I think this is similar to CIBD here, if I'm not mistaken. So they have already put in, if you use this carbon mineralized concrete, you can get ticks for green mark. And Land Transport Authority in Singapore has already spec'd in carbon mineralized concrete into their low-grade concretes, and then for high-grade concretes, you have to just prove it. Okay, so carbon cure, the use of CO2, use it for carbon, for ready mix, precast, and reclaimed water. In the industry of concrete, you have this, sludge that is coming out or from the washings. So what we are doing here is that we're putting into CO2 so that you can reclaim whatever cement or in that sludge. So just some picture of it, So this is the reaction using the reclaimed water system. And this is how it is in terms of addition of CO2, 5% here and 25%. As you can see, it's being enriched. And actually, that cement can still be reused back. And the clean water also reused back. Okay, so we are about 800 systems already worldwide. So I think we have celebrated about 43 million cubic meters of concrete. Oh, more than that, sorry. More than that, more than 43 million cubic meters of concrete that is being with carbon cure. That's about 800 systems. And worldwide, comprising different industries, precast, ready mix, and different types of cements as well. Here are some of the carbon cure project examples. I think one of the best ones will be the Arlington, Virginia, Amazon HQ2 in Arlington, Virginia. Closer to home is Singapore, the ExxonMobil gasification plant. And some of the examples in Singapore, Tuas Port, JTC, Semicon Space, and Avenue South Residence, UOL. I was trying to end it with a video, but I think we already out of time. So what I'm just saying is that before sinking it, sinking it in somewhere, probably use it, carbon cure it. So I think that's all for my presentation. Thank you very much.
Great. Thanks to all our presenters. So I think I'd like to call you all back to the stage, and we'll have a short discussion. Grilling session. So we'll have a chance for some questions at the end. So while we're up here having conversation, please keep in the back of your head if there's questions you want to bring up at the end. I'll make sure, that's always my favorite part, so I'll make sure we have at least 15, 20 minutes for questions. We're going to have a discussion now that touches on 3 or 4 different themes. The themes we have are zero carbon construction, the role of the building and construction sector in national energy transition, the cost of green buildings, and finally some questions about material circularity. And I just wanted to say before we start is that this is a complicated industry. One of the things that characterizes building and construction sector is that it's not a linear industry. It's not one that goes from A to B in a straight line. It involves many different stakeholders, many different constituents and groups of companies, professionals, academics, all working together towards common goals and objectives. There's a reason why you can't go to a store and buy a building off a shelf. Or hold on to your paper. But there's a reason why you can't just go to a store and buy a building off the shelf. It has to be designed to be appropriate for the climate, the location, the group of people that are using it, the culture of the people that are using it, the activities that are going into the people that are being done inside of the building. There are multiple different factors that determine every single building that we live in and work in. And these have to be customized. That involves coordination, and that makes the building industry quite complex. So we're going to have a conversation now, but that's important to keep in mind, is that context is everything. There is no easy answer to any of these questions, but that makes them all the more important that are questions that we ask and engage with. So we'll start a little bit with zero carbon construction. I'm going to address the first question to Gregors. What are I'd say the 1 or 2 key strategies being implemented in Malaysia to achieve zero carbon construction?
Good question. Well, I personally find it quite interesting to use wooden construction, but of course in the tropics we have a problem with termites and also humidity. But there are high-rise buildings that have been built to 11 stories height or so, with the structural system primarily being from wood.
Sorry, the latest one is in Minneapolis is 50 stories. 550.
Wow.
From
Okay.
mass
All right.
timber construction.
Okay. So, yeah, so I think that's interesting. I mean, it's not really being done yet. I know in, I think last year, the Malaysian code actually was changed. So now you are allowed to do it, but you have to prove it. I think from the fire perspective, and it has to be like a real test done where you light the construction and the fire. So it's quite expensive to do, but at least the possibility is there. So I think that could be potentially interesting, but with some reservations on. I mean, I'm not really a specialist in wooden construction, but I've wanted to see this development for a while. And then, of course, just like we saw, carbon cure, just designing. I mean, don't over-design buildings like I showed with the aircon system, right? And the chiller oversizing. It's the same with structural system. Often they are just oversized a lot. So just start with the low-hanging fruits on that.
I think also in your presentation, Gregors, you mentioned one of your examples was retrofitting. And in Malaysia, one of the things that characterizes our construction sector is we have a tremendous oversupply, both of commercial properties and housing. We keep on building more and more because there's a profit motive to building, but we actually have more housing than we have people, we have more office space than we have companies. So coming down the pipeline, that adaptive reuse and how do we transition from not only building new buildings, but making better use of buildings that we already have is a key step going forward. Ramesh, from your experience, how do construction practices need to evolve to achieve net zero targets? What can be done on site to decrease carbon emissions?
Should to ask a contractor. I look into two different perspectives. One is from the embodied carbon, the other one from just operational carbon. If I look into from embodied carbon, and I think I showed one of the slide from the construction, the product and the construction phase, which is the A, the first one. And the idea is to move to have a net zero carbon target is to look into the whole life cycle. You cannot be just focusing on that during the construction phase or the product space. You need to go end of the life. That means the maintenance of it, when you demolish the building, whether you can go back into that net zero. And if you just focus on the second one is on the operational. If you just focus on that, the whole idea about being energy efficient, or in sense of energy because related to the carbon, most of us will be told to us is like do an on-site renewable energy, and I don't think on-site is sufficient to counter it. So people go to off-site. So that's tough to go net zero. The best is to look into the whole life cycle and look into the portion from the embodied carbon. But after saying all these things, another thing came to my mind was this: do we really have the kind of a data, a baseline or benchmark to say whether we are really net zero carbon? This is another thing when we're trying to project to project, and we said, hey, are we really net zero? Where's the baseline? When you don't have a proper baseline, we're just going to pick it up some data from what is available from the industry level, not project to project. So that's another challenge that I feel I'm having that challenge now. But to answer your question is to look into the whole life cycle and look into the end of life of that project or the development you're doing, and also beyond the life, what the benefit you're going to get. So then probably we say we are moving towards the direction of a net zero carbon. Probably that.
And I think also it's important, a lot of the terminology net zero implies a give and take. We're emitting and then we are reducing. In the building industry, historically, we are emitters. And so by emphasizing on zero carbon rather than net zero carbon, it's an important distinction because it's important that we take responsibility for what's emitted at source. Buildings contribute about 40% of overall emissions. That is the overwhelming majority. So rather than focusing on the net and using future tech to offset, the primary driver is looking at how to reduce those emissions in the near term. Ibsen, last question on carbon for you is, from a more regional perspective, what challenges do you see in scaling up low carbon technology in a Malaysia context?
Go carbon cure. No, the main challenge that we have really, probably it's not only with carbon cure, but for any of those new technologies that are being put out there. Carbon cure is a new technology. I think this is probably most of you would have heard it the first time here. So, but it's been there for some time right now. So one of the big challenges is really, because it is new, there's no standard, and you know how it is in the industry. If it is not spec'd in, why use it, right? Especially when because I live in Singapore, is that with HDB, especially the housing, if it is not spec'd in, I'm not going to use it. So it will take some time for this to be digested by not only by the industry, but more so on the regulations, the regulatory bodies. And the other challenge is to who really proves it. The proof of concept. Is it the developer, the technology who developed it, with the regulator, with the private industry? Probably all I can say is that it's for everybody to really to be on board on how to do it. If one technology is very good, it really helps, then we have to be open-minded about it to accept it. So again, it's being new, regulatory, acceptance, and we always have this, let somebody be a guinea pig first
Yeah.
before really ramping it up.
I think you touch on a really good point also. It's sometimes we fall into this trap when talking about climate change and sustainability that the problems seem very huge. And it can be intimidating because these targets seem like they're very ambitious. They seem like it's something that's maybe almost in the realm of science fiction. We can't imagine the future being substantially different than it is now. And two things are really important. Like you mentioned, it's not an individual journey, it's a team effort. Every single sector, every single kind of organization, different companies, private sector, public sector, academic sector, are all working together toward these objectives. And the other aspect of that, like you mentioned, is this is an adoption curve. It's a new technology. There's a lot of new technologies. When you look in around in Malaysia, you see, Ramesh mentioned electric cars earlier. 2 years ago, they were a rarity. The technology has reached a point where it is at the cusp of exploding. And this is a combination of it's cost effective, it's a proven technology, it's an effective technology. And everyone in the room is old enough to remember a time before we have smartphones. It wasn't that long ago. 10 years ago, 15 years ago, we were using flip phones. Now it's almost impossible to remember life before that. And with a lot of these sustainable technologies, practices, electric cars, solar panels, what seems like pie-in-the-sky technology within a very short period of time is going to be absolutely commonplace. So with that, I think it's a good transition to talk just briefly about Malaysia's national energy transition and the role of the built environment within that space. So I think to everyone, in Malaysia, we're now undertaking a broader strategy for energy transition. What's the construction sector's role in meeting our development goals and commitments? Does anyone want to jump in here?
Okay, I can start. Well, I think, we can't do it without the construction sector. As you said, about 40% of the carbon emissions are related to the construction sector. And I also see the buildings as batteries in a way, as part of the solution, because as we have to transition to renewables, that means the energy is not, when you flip the switch, it's not necessarily always there, right? The sun only shines sometime, you have to maybe rely on some hydropower, some biomass and so on. So storing energy will become normal. I mean, it's already the case in my home country of Denmark, where hour by hour you have differential rates. So my friend in Denmark, he has an electric car, and he can actually charge this car for free at night, many nights. Some nights they will even pay him to take the electricity off the grid. And likewise, when you have your, let's say, car parked, it can also reverse, right? So you can tap electricity from your car or from other energy storage systems in your house. For example, cooling down the concrete slab, which we've done for several, like you saw from the factory, right? So when there's plenty of electricity, you can store energy in your building, either as cooling, like slab cooling, or charge up your batteries in the electric cars, and then when there's less electricity available, you can then tap on those storages.
Yeah, I'll just jump in here for a second. In Malaysia, because if we project forward to when increasing percentage of our energy comes from solar, the price of electricity during the day when the sun is out drops to zero. You charge your car during the day for free, and then at night you can sell that electricity back to TMB for money. So in Denmark, because the wind blows 24/7, it rises and falls with demand. The dynamic pricing in Malaysia would work the inverse. But early days, this is something to look forward to. What we do see, though, in the construction sector now is that the price of installing solar panels on your building has dropped below what TMB charges for electricity from the grid. So the Malaysia Green Building Council is a non-profit. Many of our members are building material manufacturers that have factories with big roofs. they're now almost 100% installing solar on their roof because the payback period is substantial. It's cheaper for them to produce their own electricity on site than it is to purchase electricity from TMB. And that gap is only going to continue to grow. Malaysia, we think of ourselves as an oil and gas producing country. Oil and gas are expensive. Solar is already about half the price of coal, about 50% cheaper than gas. And so we think of ourselves as being, oh, we're rich because we have gas. Gas is expensive. And we can see this coming forward with the removal of subsidies from diesel and soon with petrol. The cost of running is business as usual is just no longer good business. So it's really interesting that a lot of these solutions, we're used to thinking of them as things that are, oh, this is good for the environment. This is my business and this is something I'm going to do to take care of the planet. But that's really an old-fashioned way of looking at things. A lot of these solutions are not things we're doing to be good for the planet. They're things we're doing because they're good business. They're cheaper, they're more efficient. Maybe I'm getting ahead of myself here. But we'll come to that when we talk about the cost. So I think, Ramesh, what role do you think contractors play in advocating for and implementing green technologies in building projects? And are you seeing any growing demand for these kinds of initiatives?
Yes, there is a growing demand because of it's from client, all right? It's all the project, the building owners. It doesn't matter building or infrastructure owners. Then there is an increase from our perspective. From contract.
Maybe I'll jump in and make it a bit more specific, so it's easier to answer because that's a pretty broad question. Where do you see the majority of the demand coming from? Is it from regulation? Is it coming from private sector? Combination of the two? How is that evolving?
I'm seeing it from private sector, especially from the clients are from overseas client. They are the one who are really coming in and driving it in Malaysia. We are in a data center project. Sometimes they don't even have a green data centers. I wonder why. But there are projects that we are doing when the clients are from overseas where they feel that they need kind of, they started emphasizing to have. I wish there will be more government job or even infrastructure jobs who are looking into creating the more demand about it. That's one. But a role of, I'm trying to think, yes, we are very much contractual based. As a contractor, we cannot go and say the client, I wanted to propose you to become a more green building or more greener. We can do sustainable practice at site with a certain initiative, but to make that project or that building or infrastructure to be much more sustainable or more green in sense of, it could be energy efficient, it could be in when you talk about material in the sense of lesser embodied carbon, we are purely contractual. We have to depend on we are still top down. So that focus, maybe the building users, maybe some of you are here, you can be a client to contractors. Like Greg, you are blessed, and you have some client coming and asking you that, and I was impressed when he said, oh, so much of savings. We wish that I wish I could have been involved in such a job. So still top down. So what can we do as a contractor? So we are sometimes when we do design and build, we do start putting into some requirement, and as a contractor, one thing that we look into a supply chain, our supply chain, from our subcontractors, our suppliers. We're trying to get the best out of it, advocating this kind of green technologies. We do, because at the end of the day, it's like this. People or organization, when they see there is an intrinsic benefit out of doing this, they will come in. They will change their mindset. They will have the buy-in. They will come in. So how to advocate that to them is to also understand what are the barriers our supply chain is having. Is it purely cost, or is it that their readiness or their capabilities? All these things we need to engage the supply chain. So the more and more we engage with our supply chain, we realize some of them are already ready. They are there to come in with that kind of a green technology. Only that the market probably were not ready. And don't think that we cannot do it in Malaysia. We have all the skills. Okay? We have all the competency. Those days when I was involved in a green building, everybody had this fear. Oh, I can't construct. And no. we can design it, we can construct it, not an issue at all. And to get that certain material or technology where the cost is involved at the beginning, now its cost is dropping. You're right about the PV cells, the cost is dropping. So what we are doing as a contractor is to advocate green technology, is to try to talk to our supply chain. One is talk to them, create the awareness with them, try to understand what kind of a barriers they have, what limitation they have, how can we support, and work with association like Master Builders or even Green RE and all that association, even MGBC for that matter. So how to move around and create this kind of a full awareness. If your supply chain have full knowledge about it, you're there. Then you just can say, I want to have a more green material. I want to have this. They'll be ready. They will provide to you.
I think it's a good answer. And I think to jump in, you touched on a very good point, which is that in Malaysia, we have a lot of opportunity there's a lot of potential in our flexibility. We don't have a singular top-down approach. Like if you look at the Singaporean approach, government says this, everyone follows. Malaysia is a much more dynamic and complex operating environment. So we have leadership from multiple stakeholders, oftentimes at the same time, sometimes contradictory, but it's a much more diversified approach to transitioning the economy to looking at the economic systems. We have government regulation, which is stepping in with Energy Efficiency Act. We have private sector leadership. We have the ability to engage with multiple international standards. So like you mentioned before, the regulations, we get this knock-on effect because if we're exporting to EU, we then have benefits of compliance and competition of exporting to comply with regulations from overseas. So it's not just a singular approach. Government sets this regulation, everyone follows. There are multiple stakeholders, multiple prongs operating simultaneously. I think I'm going to move on to my favorite topic, which is money and the cost of green buildings. So I think I'll start with Gregors. How do you mentioned a little bit in your presentation with Factory and Forest and your clients saying they want a cheap building. How do you approach balancing upfront costs of green materials and technologies with long-term operational savings in green building projects?
Yeah, good question. Well, first of all, there's a big misconception about how expensive green buildings are. So quite often I hear people say, "Oh, 30% extra construction cost." If you do it right, it's maybe only 3%.
Sorry to jump in. 0. If you do it right, there's no additional cost.
Yeah.
Go ahead.
Yeah, that's right. So. Yeah, exactly. So it is all what's your base building. But we actually had an interesting case studies just around the corner here. The KKR2 building, the headquarters of JKR, the one that twists a little bit, because that was an open tender, and for this building, the requirement was to make it an energy efficient building. And we went in with, I think it was 7 of the bidders. And then the rest, we were not part of those teams. And they published, because it was an open bid, so we could see what was the price, the bidding price. And then, so the JKR team basically evaluated, of course, the price, but also how efficient is this building. So when we plotted it out, efficiency versus price, we could actually see that the cheapest, and we put a line through, you could see the more efficient you made the building, it also became cheaper. So we ended up winning the job. And I'm not exactly sure what the other teams did that we didn't work with, but I think they just priced in some extra cost because, it's supposed to be an efficient building and we probably have to use more expensive glazing or whatever. We also did that in our project, but then because we ran the energy models, we would see, okay, we've spent more money on the facade, but then we can downsize the cooling system. So therefore the overall cost didn't go up. So there's not necessarily a conflict there.
I would just add to that. It's that the misconception about building cost is that the cost is proportionate to performance. I want a better cost. I want better performance. That means, well, I must have to pay more for it. That's not how buildings work. When you design and build a building, you build that building to a budget. So if I showed you, I'm going to point randomly now, but if I have two libraries, I say, oh, is a library an expensive building? No, it's not that kind of building that's expensive. It's what was the client's budget? You can make a very, very excellent library with a low budget. You can make a very excellent building with a high budget. The budget does not dictate the performance of the building. And with green design or performance, with sustainability in construction, it's the same thing. You could design a very expensive building that is incredibly inefficient. You can design a very expensive building that is extraordinarily efficient. You can design a very inexpensive building that is designed to prioritize efficiency, and you can design a very inexpensive building that is really inefficient. It's what do you prioritize in construction that dictates the building performance, and then we all design to a budget. You don't. So I think that it's really a misperception that if you want something better, that it necessarily comes with a price tag. Ramesh, are there specific ways that contractors can help reduce costs in green construction? I mean, one of the things that I think Gregor's touched on is that, and you touched on during our presentation, is that efficiency is less expensive. If you have any practice and you can design it to be more efficient, it's also cost savings.
I'm not going to touch on design because I think Greg has a mention on his slide. I'm going to purely look into our contractor's perspective. For us, cost saving is extra profit. So we look into a few things. What are the costs in the construction? Your workers, your material, your machinery, which is then the time, the duration of the project. Okay? So we look into all these things. How can I reduce costs on every aspect that let's look into the workers. If I can reduce, I can be more efficient with less gain of workers. That means I have more skilled workers, lesser general workers, and I can have a better productivity. That's cost saving. How to do that is, so when we embark, we realize we need skilled guys to do the work. And be mindful, in Malaysia, those workers are coming in, they don't come in with all the skills you think they should have. We are the one who trained them. Slowly we passed on, then became skilled. I remember when I started, those guys don't know even how to hold a hammer. I came from a very simple background, so I was a carpenter before I even studied to engineering and all that. So I know how to hold a hammer. These guys don't even know how to hold a hammer. And imagine that I'm going and supervising them. So we understand that. So then we have what we call our construction manager or foreman who can guide them. So in that way, you are more productive. More productive, more efficient, so I have lesser workers. So you have to focus that, then it's a reduction cost. Next, I said material, about waste management, efficient use of material, all I mentioned already earlier in my presentation. You can plan your work. So most of the time, another example was this. I was at a site, these guys were doing brickwork. You'll be surprised the wastages was like 20%, purely because of one thing. We didn't supply them, or my subcontractor didn't supply them with a proper hammer to break that brick. And we were supplying bricks to them. They were just whacking the brick. Okay, can't fit in the size, throw. And imagine those days we have chute coming down. Brick coming down from the chute, the noise level. So we have to take action. So we took action. We went to the subcontractor, guys. So that's one. Look into the whole process, the methodology, the work methodology. You can save your cost. Saving on sending waste. We did a simple study about amount of waste we sent to our landfill. It came to millions. We said, that's a lot of money. a lot of resources we're sending to a landfill, and it's all money because we're supplying the material. If I save that, as you said, project come out with a budget. If I save that, I'm saving on my construction budget. So we look into that too. So, ladies and gentlemen, there are a lot of opportunity out there. Right? Talk to the people like us. I say old dogs got a lot of tricks. So come and ask us. We will tell you. And then about machinery. The machinery is like tower crane dependency. Tower crane uses a lot of energy, electricity. And you want to have, if I can save that energy on or lesser usage of the tower crane, what can I do? Can I have something else? Can I have a different methodology? Which one of the slide I showed you about automatic climbing system. Those days when you have a formwork coming in, tower crane to lift it up. No, this is self-climbing kind of a formwork. I will save my tower crane energy. I will save time on using that. I'll use tower crane for different purposes. And saving costs. So you can look into all these things. Apart from that is digitalization. This is slowly we are moving. Oh, we can see beam is helpful. Let's do it. So we started about my beam stuffs at the back. They came in and we set up our own beam and we start looking into how beam can reduce your defect. How can be more coordinated work. I started in a construction drawing where probably we don't know, we overlay 2 drawings and see that superimposed drawing, coordinated drawing. No, just model it and give to our guys to read and they were able to pick it up. The less defect, save your cost. The well coordinated, less defect too, faster. So also you can save costs. The other one, of course, in Malaysian government, we are now through CIDB, the focus on IBS, prefabricated construction or modular construction. That is another thing. So we not only look into prefabricated construction, we also look into our system formwork. How system formwork can aid you? You're just using a conventional formwork of a timber waste, etc. Looking to a system formwork. So these are the easy, like you say, low-hanging things. You can look into that and save your cost. So that is from contractor. If you look into the design, I think I would always say, hey guys, focus on the passive design.
I think
Mitch, you touched something that very close to my heart. I have to take your time telling you the whole story. Thank you.
Well, I think you raise a really good point. Sometimes we lose focus on things that we take for granted. So the idea that our heavy equipment is run on diesel fuel, this is a huge cost, and converting some of these equipment to electrified machines cuts the cost of fuel by 50%, 70%. So it's taking a step back and questioning some of our traditional practices. There's a lot of opportunity for increased efficiency.
Nowadays, at our site, we will always try to get that energy supply from TNB rather than depending on genset. So it's always like we have a target. Hey guys, get it done within 1-2 months. I don't want to have the dependency on genset. This is what we tell our project managers. So if we can energize, get quickly done. So if you look into our work program, sometimes we put it there so get that supply rather than depending on genset. Because we realize the emission coming from there, the money that we spend is more than we're spending the money with TNB. Cost saving.
That's a great approach to decarbonizing all of our environments, is getting rid of all the little gensets we have lying around. Ibsen, how do you address concerns about cost effectiveness of using low carbon materials as compared to traditional materials? And I'll preface this by saying that we saw in other construction materials like paints and light bulbs, that usually when a technology hits the market running, there's a premium placed on it. And this is true in sustainability, from dishwasher detergent to a lot of the greenwashing that Ramesh mentioned at the beginning. You slap a green on it, the price goes up by 15%, 20%. People associate something being sustainable as being more expensive. So in your experience, what are some of the trends that you see in terms of that adoption related to cost?
Probably those who are business-minded will say, if there's an opportunity to increase price, why not? If you give a premium on it, why not? However, there's always a flip side to it in terms of sustainability as well. As what you have mentioned, there are sustainable materials which are less carbon intensive that you can really use. probably the first investment, initial investments, is going to be very high, but in the long term, such as what Gregor has mentioned, maybe probably not. Sorry? Oh, sorry. Okay, so probably the initial investment is going to be high, but long term it's going to be lower. That one I promise you. So don't look at it on the initial, but look at it on the long term. Again, it's the same thing. Solar panels have been very expensive at the first, and then it became lower. Now, as you were saying, it's about 50%. I'll go back to the industry of making concrete, as I've mentioned, such as the ones LC3, calcined clays. Even though it's going to be an initial investment, overall the energy dependency on that one or carbon intensity of that one is lower. So it will be lower. So for me is that I always believe that yes, sustainability at the front can be expensive, long term it's not. You can always find something that is less carbon intensive materials that you can use for your daily, for your use.
And I think it's interesting with a technology like Carbon Cure that's technological intervention at source, the opportunity for scale is tremendous because you're implementing it at the plant. It's behind the scenes, to the end consumer, it may be invisible. For the manufacturing process and the concrete manufacturers, it's something that adds to their productivity and reduces their costs substantially.
Probably I would also add to that in that very specific point, because it still is a new technology, and even those who are CO2 suppliers, they still price it as the same as what you give it into the beverage industry. However, when the industry is going to adopt it more and more and more, that cost will go down. That's what I think. Again, it's only in the initial, how the adoption is. If everyone believes it's sustainable in the long run.
Okay, I think I want to open up for questions. Anyone in the audience have questions? I have a whole list of things that we can keep on talking about, but I'd rather hear from you. Does anyone have anything? Yes.
Lon, hi, sorry, testing. Hi, it's still on cost. My name is Rizal from Bank Pembangunan Malaysia Berhad for the PMB. So I've seen in the banking sector and financial institutions, a lot of us moving to green buildings because it's because. So the move towards green buildings, meaning our HQ moving towards new green buildings, is largely to show that our climate commitment. But I'm looking at the pros and cons for this move. I don't feel, in terms of the cost, it's not really cost saving. Can you give us some comment on that? Because the other side of it is, if we stay in the old building, retrofitting it apparently costs way higher. But in this forum, what I'm hearing is it doesn't cost higher than moving to a green building.
Okay, it's a good question. I think thank you for the question. I think there's a few different issues that are happening simultaneously when we talk about cost and finance. One of the things that I notice is that when people talk about green finance, green loans, green building, they oftentimes, by qualifying it, saying this is a green loan, it gives someone the permission to think of outside just common sense. So rather than look at it as a green loan or a loan, think about what are the basic fundamentals of lending. It's risk. You want assurance that that's a good investment. And one of the things that we see when we talk about green buildings is that a green building, an efficient building, a well-designed building is a safer investment. And so looking at it from the perspective of not just cost, but also risk is incredibly important from a finance perspective. a lot of what a loan officer does or a finance officer does is try to evaluate risk. And they look at the financials, what's the return going to be. Green qualification or an indication of the building's environmental performance is a very reliable metric for how well designed that building is, how easy it's going to be maintained, what the profitability of that building is. So sometimes by looking at just what's the cost, can we justify the cost, we're missing the more important or just an equally important side of the equation, which is that these are indicators that give us a different set of information, which is valuable for just loans, not necessarily green loans. Anyone else have anything to jump in?
Probably just my personal experience, because I was just dabbing into these banks in terms of loans, looking at it. So I went into one of these banks, and as what you rightfully said, Mitch, that they qualify it. So there are certain criteria there wherein before I give you the loan, are you putting in how many ticks of appliances? Are they more efficient, right? Do you have a temperature regulator in your home? So all of this adds up to something that is ticks, and then they give you at the end is that, okay, you're certified for your home that you are doing either renovation or when you go in, that this is lower energy intensive, then they give you a lower rate. So in a perspective of bank, is that I think it is. It gives you more.
I think your concern, your thought was different. Correct me if I'm wrong. You're saying that why must I go to a new building when Greg had mentioned retrofitting is better? So if you recall, Greg showed two things. One is on energy, and he also touched on the embodied portion. All right, that is the way forward. You don't only focus retrofitting a building and you say, oh, it's going to save energy, but at the same time you're going to demolish all kind of a thing and send it to a waste, then you're going to put new material in and all that. So look into that. That one slide that I mentioned on the whole life cycle about it, during from the product to the construction, the A until the D. So if you look into life cycle impact, that will be good. So from your perspective for a bank or even new buildings, if you see what, Greg, I'm going to touch your slide, all right? The younger generations, they feel they need probably a building looks more sassy, better, looks greener, and they wanted that kind of a space. They would have Googled office, how does it look like? They want something like that. That creates another thing, the working environment, conducive environment. Don't only think about energy. The other thing is to look into, in my work environment, with like more view outside, you feel there is a bit of, I can mingle around, that is, it's like open space, that kind of a thing will also increase the productivity. So retrofitting a building, if you can do all that, and that is a marvel it did, all right? Great. If you can't do that, what do you do if you're from a management? You start looking to the whole, I need to bring in new guys. The new generation must come and work with me. Me, I don't care. You give me a small cabin, so I'll work. I came from a very, I started working in a 10 feet by cabin, that's my side office. I told you my side toilet, right? So y'all don't care. But younger generation, no. So the bank would have started looking into so many aspects, not only about the location, the type, the design of the building, the energy saving, the saving in sense of the material. I need to put it so if I cannot retrofit that, the best option is to go for a new building. So, that's why it requires that kind of a team. A client must start thinking like that. The consultant also must think like that. The contractor also must have the same mindset. Then probably that's the reason the banks are going. Although there are one here, they wanted to just show off, showcase their building is great, but I think not all. They are already now with that, we have that awareness already. trust me, those days, no, probably nowadays, most of them, they already have that comprehensive awareness in sense why the green building are benefiting not only in sense of energy, also into your well-being of the occupants.
Holistic approach.
Yeah, exactly. I just to add a little bit to that, but I'll summarize almost. I mean, the problem is the biggest benefit of a green building is not really factored in, and that is exactly the positive impact on well-being, productivity, people being less sick. So normally it just comes down to, okay, how much is the energy bill reducing? And of course, energy prices are artificially low in Malaysia. But even with these artificially low prices, we can still make a good business case in quite often, right? But if you start paying the real price, I usually like to tell that when I go back to my home country of Denmark and I filled up my parents' car, I paid 630 ringgit, right? That's the real price of energy. So, and I mean, carbon taxation and all that is coming. We don't have it yet, right? But just be aware you are living in an artificially cheap world.
He's comparing his foreign salary. You don't compare with our salary. That's totally different.
But it's I mean, Gregor's raises a good point. Even with the extent of energy subsidy in Malaysia, the ROI for these kinds of energy efficiency retrofits is 3 years, oftentimes less. You know, what kind of investment in anywhere in the world do you make your money back in 3 years? You double your investment every 3 years. So these kinds of underlying financials speak for themselves, and that's with the energy subsidy. And we're already seeing those start to kick up. You know, the price of my diesel car is close to 200 ringgit, and not 600, but it's getting close. And so we're seeing people drive electric cars now, not because they're saving the planet, but because it costs a third to half to pay for electricity as it does to pay for petrol. And that's with the current price. Now, when the subsidy goes up, then it's going to be a fifth of the price. And it's for a technology which is far more efficient, easier to maintain, cheaper to purchase at the outset. So it's a little bit like walking around with a fax machine rather than a smartphone. You know, the fax machine, we don't use them anymore because it's an obsolete technology. And increasingly, those fossil fuel-based technologies and economies are expensive, not cost-effective, and increasingly obsolete. It's not an overnight transition, but this is the direction that we're seeing the industry move. Do you have any other question? Yes.
Hello. Okay. Thank you, panelists, for the wonderful discussion. I'm Venus. I'm not in the construction industry. I actually graduated from law, but I grew up with parents in the construction industry. My mom is in concrete and my dad is in supplying door frames and windows. So I think my question is more directed towards Mr. Ramesh, because I know in the industry there's a lot of from experience from listening to my parents when they talk to their clients, it's usually a lot of relationship based. So because I have a good relationship with this supplier, any new projects, I will approach them first. And there's also usually a lot of discussion on reducing the price, or can you give me a cheaper price? Because we've been doing business for so long. So I think my question is more how do you get your suppliers to be greener? To encourage them, could you make if you are green certified, or if you reduce your emissions more, then there's a higher chance that we want to take you for this new project. Or I think it's more how you said, advocating for this, how do you make sure that your purchasing team as well looks into this? Because I'm not sure if it's just you as the general manager that has this passion for this thing, how do you translate it into your whole office? Thank you.
Venus, thank you. The whole trick is to convert the passion into a policy. why I say so. If you don't, the organization don't have a policy to give that advantage or premium to a green contractor or even green supplier or green material, it won't happen. Why it won't happen is, end of the day, you will still go back to the cost factor. So if you're pricing it, and if I have two material equivalent, and depends who is going to give me the cheaper price. I'm talking about the spec, in sense of spec, right? I'm not going to touch on the spec, which is on the green aspect. Just on the specification of that, it can be a window frame, doesn't matter what other material. Spec to spec, somebody may have, even though maybe got a different way of doing it, so they can give you a lower price. Until the day comes when we can change that policy, then he says, if they are giving us a bit of a better report in sense that they are practicing more greener, right? Greener in this sense, I'm talking about sustainability, not only on the environmental aspect, I did mention about the social portion. And I'm going to give that advantage to the supplier. So what we are doing now, this is what we have done a couple of months back. We engaged our supply chain, all right? I think one of our suppliers is here. We spoke to them. You have asked the same exact question that this gentleman asked me. Please raise your hand. Is that? He asked me the same thing. And I told him, frankly, it's not in our policy yet, but I wish it will be in our policy whereby we will give you that advantage. And we are advocating that. We hope that will happen. So those of you suppliers or the subcontractors are moving towards the direction, and you come and maybe you have a checklist, you say, oh yeah, you care for the environment more. You have a better in sense of labor care. I'm going to give you an additional point. So you will be on my top 10 list of supplier, okay? That is my wish too. And I am advocating that, that's my wish. I'm also asking my management also to consider that. Okay, I hope so many other management also will start doing that. Let's hope that becomes a fruit on one day. I'm wishing for it too. I hope you answered. I'm very truthful about it. I don't want to greenwash that also.
And there's another aspect also, which is regulation. And so the direction that the industry is moving in is one of disclosure. And these disclosures now are voluntary, but they're very quickly moving into the realm of mandatory. So we see coming from EU, like we mentioned earlier, if you sell any building product in the European Union, by 2026, you have to put a mandatory environmental product declaration on that product. And we already see that here in terms of, if you buy a car, the fuel efficiency of the car is stated clearly on the label. This is the direction that the construction industry is moving, that all of our industry is moving. So for now, it's a handshake and a relationship. That handshake and a relationship within the next 3 to 5 years will be handshake, relationship, and disclosure. So that when that disclosure is there, then you're evaluating, can you give me the best deal? Can you give me 5% discount? And by the way, your carbon emissions of your product are 20% higher than your competitors. So it starts to make Ibsen's job much, much easier, because when concrete manufacturers around the world are now declaring this is the CO2 emissions per meter squared, here's a technology that gives you a competitive advantage, this becomes a no-brainer for business.
I would like to add on that. We touched on EPD. So through a few organizations that I'm involved, Green RA and all that, we started talking about environmental product declaration purely to give awareness to our supply chain. It's not only now, it has started a couple of years back. So when we mention EPD, to our surprise, not many of Malaysian suppliers are aware of it. But slowly the awareness are increasing. You can see that when you say EPD, everybody is, hey, what is heck is EPD? They don't ask you that, they know what is EPD. So you can see that the change in the mindset is taking places. The awareness is increasing. But are we ready for EPD? EPD doesn't only give you on a GSG, it gives you the whole issues with environment. You have to declare the water use, etc., and all this kind of thing. And you can get your product to EPD and you get certified. And I know some of the suppliers here trying to work on it, but have a baby steps. So just look into your production energy first, report it. So at least you are better than others. That's why I look into the A1, A2, A3 in sense of calculation in life cycle. So maybe you start working on that and you are better than others. So that's one baby step you can start doing. So that also included into some rating tools, like even green RE rating tools. If you look into the building, if your material, you can prove to the A1 to A3 on the carbon calculation. By right, your product are considered greener. Then, of course, so many other eco-labeling available in Malaysia, and you can go for it too. That will be another better steps. That's just, I wish there will be more product EPD in this country.
Yes.
Hello, my name is Azri. I'm a contractor. So my question is on contractor perspective. So I very enjoy the panelist discussion. Mr. Ramesh, he said that towards sustainable, we have a few obstacles. One of it is the environment, and the most critical part is the commercial. And then Mr. Gregan come and he said it's not a factor. We can build a green project with cheap. So my question is to Mr. Ibsen, because for a company, like say a contractor, to adopt carbon care technology, what's the scale of the project? How many meter cube for the building to be commercially viable to adopt your product?
No, it's on the dollars and cents now.
Thank you for
No, in the end, everything will boil down to dollars and cents. All technology will always have a return. So it's just a matter of how that return fits into your business. Can be high, can be low, depending on where the business is. So there will always be a return on it. It can be high. So it's just a matter of just trying to understand what you have right now and where this technology will play onto you. So definitely there is a return on it.
Can you sell Carbon Cure directly to an end user, or is it B2B technology? Meaning can you implement a Carbon Cure on a specific construction site? I think was the question.
Okay. Our end customer is always on with the concrete producers. So we are in coordination with them on how we can help them sell this concrete, greener concrete. And it gives them some sort of an incentive going into the developers, no? To say, give them some ticks, no? In order for them to be pushing them up to the list, no? As it's not only on cost, but it's an holistic approach on how this would look like.
So, okay, let's see in Southeast Asia. I believe it's only in Singapore that's implement a carbon tax, I think. So in Malaysia, we still implement. So how you convince the concrete supplier to use the carbon care technology? Let's say in Malaysia, we don't have that carbon tax.
Right.
So how you sell to them without?
Okay. I mean, it's the same thing. Even before where there are no carbon taxes in Singapore, it was already being implemented. This technology in Singapore has been there since 2019, 2020, before any carbon tax. So now it's just the adaptation is now getting more and more and faster because of the carbon tax. So that is from the government. Now let's go to the perspective here in Malaysia, wherein there's no carbon tax yet. Again, we still go back to the basic where Carbon Cure's business model is in terms of it. It's there. It's there. So it doesn't, anything that is on carbon tax is just on top of it, makes it better. But what it is right now is already good.
So you mean you can sell your technical advantage for the product?
Yes. I think as I have mentioned in my presentation is that when you use this Carbon Cure, the CO2 injected into the concrete, it enhances the performance of your concrete. Now, in any concrete industry or any, if you increase your performance, you're not going to sell that added performance. No, as you know, you can say I'll sell it plus $3 per meter cube. No. So what you can do is that you can do whatever you want with that added performance, right? In concrete industry, even in cement industry, what is being usually done is to put cut the cement, then they would cut the cement and then put in an SEM. So there's the trade-off, and net effect is that you will get your ROI.
I think we have maybe the last question. Thank you.
Hi, my name is Jane. I'm in the research area, so I'm actually a research assistant. My background is in counting costing, so I'm in procurement side when I was work last time. So my question would be to Mr. Gregor. So you have mentioned about retrofit, right? So is retrofit feasible for minor kind? So like let's say in not looking at high rise, looking at low rise building, especially because I mean buildings are oversupplied right now. So what are those? A bit older, I would not say old, like maybe 5 to 10 years or 15 years. So this kind of small scales retrofit, like changing the single panel to double glaze, or having insulation paint towards the facade or the roofing part. So retrofit, a lot of times when we look at retrofit projects, is looking at active systems and passive systems. So active is obviously because when in Malaysia, you need air cons. So is minor retrofit like touching on facades only, it's feasible? So that would be my first question. The other one is, let's say I'm in a small builders company, so I'm just a small subcon, and I would like to be innovative, like, oh, I want to try what is sustainable. What software, I mean software like nowadays we have Autodesk, Revit, Graphisoft, those, they have 3D models that you can use, very good. That also includes energy modeling inside as well. So for a small scales buildings, for user to be more interactive, what kind of software would you recommend? Yeah. And as for one more is, one more is actually regarding towards small builders, right? So sorry, this can be like you guys mentioned about the profits, right? As a small builders, when you're doing this kind of like minor retrofit projects, the profit will be less. Is it worth taking it? And also, as small builders, small contractors in this sense, will it be in terms of working on a small contracts rather than working on big? A lot of contractors will want to take big jobs, like doing new construction where we have more profits. Like small retrofit projects, will it be something that we would like to look into future, because we are going for net zero, right? Yeah, so that is my question.
Yeah, good luck.
Ooh, memory test. Yeah, okay, so let me go through. Thanks for those questions. So the first one, can you retrofit like small projects, low-rise projects? Definitely. I mean, we've done a small retrofit, just 200 square meters or something like that, and managed to save 53% of the energy. And the office, I mean, it's a small office, and it looks completely like a new building. And this building was only, I think it was 10 years old or something when we retrofitted it. Yeah. So yeah, so I can share that. It's on our website somewhere, but I can give you the link later.
I think I'll also jump in here for a second, which is that when we talk about retrofit, there is no one single thing that we mean when retrofit. So it's really important to think of it in terms of retrofit and maintenance. And so buildings require upkeep. They require, your aircon has a lifespan. Your light bulbs burn out and need to be replaced. And so one of the things you can do in terms of the smallest amount of retrofit is when your light bulb burns out, have a policy in place to replace it with the most energy efficient available, because it costs the same. You know, a low efficiency light bulb now costs exactly the same as a high efficiency LED. So if you're replacing an old system with the same system, you're spending exactly the same amount for lower performance. And so that's the first sort of bar of retrofit. I think people take it for granted for sometimes. Air cons need to be replaced after 15, 20, 25 years, and if you replace your chiller or replace your air con for the same price with the most efficient model available, you're spending the same, you're not spending any extra money, and you're cutting your bill by 20%, 30%, 40%. You're getting a return from that. So that's, again, part of what we need to adjust is our mentality. We're not just retrofitting and upgrading and spending money. We're already spending money on our buildings. It's just spending that money in a way that prioritizes efficiency so they're cheaper to run and cheaper to operate. Number 2 question was
Software.
yes, software, and number
Yeah.
3 question was
Small contractors.
Small contractors. Okay.
Yeah, so just one more thing on the small retrofit. So that particular project, we also retrofitted the facade, very simple one. We just left the original glazing, which was quite poor and leaky, but we just put a clear piece of glass on the inside windowsill. And this way we managed to seal up the building, and that meant we didn't have all this loss of aircon through the sort of gaping windows. And also we got a much more quiet office because it was facing a busy street. So quite a cheap way, and this glazing we just made so you could unscrew it and remove it for cleaning once in a while. Yeah. On software, yeah, there's a lot of, I think SketchUp is a software that also has some, I think it has a link to Energy Plus, I think, so you can do some simulation there, but I think nothing really, you can always simulate anything, but I always tell my own staff, don't just jump into the simulation, think, right? So most of my innovations I just do with a piece of pen and a pencil. Just draw it out. You have to have the concepts right, you have to have a good understanding of building physics, because a lot of people just simulate, oh, result comes out, great, I think this is right, but often it's quite wrong, right? So the simulation is not really the answer, the understanding is the answer. And the last one on profit for small contractors, I'm not really sure if I'm the right person to, but you can always make a profit, right?
Mr. Ramesh.
Yeah.
Yeah, like your point of view, because you guys have IGM have their own BIM teams as well, but what in terms of low profits, I will say, because it's working on low skills, like if you're touching on low rises buildings, so will contractors take up these jobs?
If there is profit, definitely.
3% enough?
Not enough.
That's why.
Those are the days we are talking about double-digit profit. Nowadays, you get double-digit, you are great. So we are talking around 6-7% kind of profit is great enough. Unless you move on into a different type of construction, a different type of building. If you're talking about apartment and building and all that, the margins are already very thin. Hence, you have to start looking into other ways of saving your costs, construction costs. So probably your margin can be better. But for a contractor, small contractor, is understand that why am I taking the job? Do I have that kind of skill and knowledge? Then go ahead. The other way is when you look into certain things and we engage our contractors and subcontractor, we talk to them in sense of work methodology, because they know better in sense of the work methodology. So that's one way we also save, and we hope they also will save. And is sharing the information and knowledge. The problem is when people don't communicate in sense of doing certain work, and hence up, there'll be a lot of defect, a lot of other issues. So this is what I see the problem. If you can be a small contractor, if you know you have that kind of a competency, that kind of a capabilities, go take up the job. Whether it's a green job, what's so great, what's so big difficulty of doing a green building? There's nothing difficulty in it. It's just almost the same thing, only you're changing the materials and changing certain, when you design it's in a construction drawing, what's difficult for you to construct? Talk to the guys who already have done some building. So when we started those days, the first green building, that's what we thought. Oh, it's going to be tough. When you realize the construction drawing, the contractor, the consultant came in. Yes. So what? Nothing great about it, right? So yeah, but 3% is low. We also don't want to find doing it. But when a difficult time, go ahead and look into a lot of other opportunity where you can really save your cost. Most of the time, our margins are eroded because of waste, inefficiency, and all that. And this is what we see, that subcontractor will come to us, I lost, because when we look into the waste, they'll be like wasting their material. So communicate, please communicate with your main contractors and all that. Have a better work methodology, look into the coordination, and sometimes you're idling. Small contractor come, they don't have enough thing to do. Main contractor don't give you enough to do because they didn't coordinate well. Talk to them, that's also another issue. And I don't want to, nothing is being contractual, right? Less and less of small contractors are not that contractual, right? If you are contractual, there is also opportunity. My guys will go back and tell my boss, yeah, I said it to you, but that's another way, okay? Nothing wrong being contractual. End of the day, it's all about making money in a very sustainable way.
Okay, thanks everyone for your time this afternoon, and please feel free to come up to any of us after the event. We'd love to meet you. Oh, is there a QR code? Was there
Scan the QR code, and we need your attendance. They're not going to pay our salary. There are a few of you attending only.
Oh, we're getting paid for this?
No.
I think there's a QR code for you to register
No.
attendance and give feedback.
I think we owe it to the organizers for this venue. They would have forked up so much, so let's give your attendance as just a gift to them too.
And thank you, everyone.
And apologies if anything wrong, anything lacking.